Hello everyone, here is a question based on cross-Dalton condensation and stoichiometric moles. In the Claisen-Schmidt reaction to prepare dibenzalacetone from 5.3 gram benzaldehyde, a total of 3.51 gram product was obtained. What is the percentage yield in this reaction was? We know that Claisen-Schmidt reaction is a specific type of cross-Dalton condensation. What I mean by specific is that we need to have a aromatic carbonyl compound without alpha hydrogen. So that one here is benzaldehyde. That doesn't have any alpha hydrogens. This is reacting with a ketone, and the clue given here is dibenzalacetone. So that means acetone is the ketone that we need to consider as one of the reactants. That gives alpha comma beta unsaturated carbonyl compound. So that's what we get in aldol condensation, alpha comma beta unsaturated carbonyl compound. We have 3 alpha hydrogens here on this side, and this side too we have 3 alpha hydrogens. What happens when we put the base is that in the condensation a water molecule will be eliminated. So basically, this will be eliminated, one water molecule. So first we will have this product CH double bond CH and then C double bond O and then CH3. Now we require one more mole of benzaldehyde OH minus, and then one more water molecule will be eliminated. Then we will get the alpha comma beta unsaturated carbonyl compound. So the final product is this one, and that is what we are calling it as dibenzalacetone. CH, C double bond O, and then again CH double bond CH, and then one more phenyl ring on this side. So this is the alpha beta unsaturated carbonyl compound. Now in this reaction, what we need to understand here is that we require 2 moles of benzaldehyde to get 1 mole of the alpha comma beta unsaturated compound. So that means in terms of stoichiometric moles, if we think about number of moles of benzaldehyde divided by 2 is equal to number of moles of product. If we want to put divided by 1, that's fine. So this is the stoichiometric ratio here, because if we have 2 moles of benzaldehyde, you will get 1 mole of product. If you have 1 mole of benzaldehyde, then you will get half a mole of the product. But if you have half a mole of benzaldehyde, then you will get 1 by 4 mole of product. That's why we are dividing it by 2. This is the way we write the stoichiometric moles. So based on the stoichiometric moles, we are going to calculate the theoretical yield, because percentage yield is actual yield of the product divided by theoretical yield of the product. But here the theoretical yield we are going to calculate based on benzaldehyde itself, because based on the stoichiometric mole ratio we can find out the theoretical yield of the product, and then based on the weights given we can find out the actual yield. That's what we are going to do here. So this means let's find out the number of moles of benzaldehyde. We know that number of moles is equal to mass divided by molar mass. Mass given here is 5.3 gram. So therefore 5.3 gram divided by molar mass of benzaldehyde is, we know that molecular formula is C7H6O. So this means 7 times 12, that is 84, and then 6 times 1, 6, and then 1 times 16. So this means 10 plus 6, 16, remaining 1, and then 10. So 106. So 106 gram per mole, which we can write it as 53 times 10 to the power minus 1 divided by 106. So this is 1 by 2 times 10 to the power minus 1. So therefore this is 0.05 moles. So which means number of moles of benzaldehyde divided by 2 is the theoretical yield. So therefore 0.05 mole divided by 2, this is the theoretical yield of the product. Now let's find the actual yield of the product. For that we need to figure out the molar mass of dibenzalacetone and the weight is given. And for dibenzalacetone the molecular formula is, we have C6H5 here and then we have C6H5 here. So together that would be C12H10 and then we have 4 more hydrogens plus 5 carbons, so 4 hydrogens and then 1 oxygen. That's what we have. So together it would be C17H14O. So that means 17 times 12, that would be equal to 204 and then 14 times 1 and then 1 times 16. So that would be 16. So therefore this will be 234 gram per mole. So therefore 3.51 gram divided by 234 gram per mole. So let me write this as 350 divided by 235 to make the math a little easier. So in that case 7 times 5, so this will be 70 and this will be 4 times 5, 20 and then remaining 3, so 47. So therefore we can further divide this and that would be 35 divided by 23.5, which I am writing it as 36 divided by 24. So this means this is equal to 1.5 and we have 10 to the power minus 2 here. So therefore this is equal to 0.015 moles. So that's the actual yield. So therefore percentage yield is 0.015 mole divided by the theoretical yield we got is 0.05 moles divided by 2 times 100. So when this 2 goes up, it would become 0.030 divided by 0.05 times 100. So therefore this will be 0.6 times 100, which means 60% is the yield. So therefore 60 is the correct answer.